Yes, welcome back. So in the previous topic, we were discussing regarding the Morse circle construction. Then we discussed about the what is the procedure we need to follow in order to construct the Morse circle. So then we have discussed regarding the what are the conditions that should go into that it will be applied for the Morse circle in order to construct the Morse circle. So as we have discussed in the earlier that Morse circle is nothing but a graphical representation. So in order to find the given values or in the based on the numericals, we need to find for the different condition by constructing the Morse circle. See, by constructing the Morse circle, and then we can able to measure the values, and we can able to find out the for the given conditions. So and in a few cases there is a chances to compare with the analytical with the graphical method, that is by using the equations we going to find the values. So similar way we need to find out the values based on the Morse circle construction, then we need to identify that values and we need to compare that. So this is what we're going to discuss in this topic, that is a Morse circle construction. So now we're going to see how we're going to identify the different planes or different stresses on the Morse circle construction, and how we're going to construct that particular Morse circle. So you can able to see this diagram. So in this it is actually it is not taken to the exact values, so it is one of the representation, but in the actual condition the graph will vary according to the values. So initially in the whenever we need to find out the any numerical sorry any graphical representation values, so some given conditions will be there in the problem. So based on that condition, initially we will going to draw the Morse circle. Then on that, based on that conditions, we should able to identify the different constructions, different coordinates and different construction. Based on this only we will going to identify the given conditions like normal stress, principal stress, maximum principal stress, minimum principal stress, tangential stress. So like this all the things we can able to identify, that is principal stress, maximum principal stress, minimum principal stress, tangential component and a normal component, or a shear stress, maximum shear stress, minimum shear stress. So like this all the things that we can able to easily identify this. So first step is whenever we need to construct, so we need to draw one axis line. See, that is to start with the above the axis or below the axis is nothing but again the based on the conditions. So conditions is nothing but positive and negative clockwise. So what which are the things in the earlier topic what we have discussed is nothing but whenever it is rotating in a positive, that is which are going to rotate in the clockwise, that we are going to consider as in a positive, and which is rotating in an anti-clockwise, that is what we are going to consider as in a negative. So here what we are going to identify when we used to draw that. So you can able to see this above this axis, that is what we called as a shear stress, what we are going to consider. So that is about the below the axis is towards the downwards what is there, that portion we are going to consider as a positive, and above the axis above the this center line which is there, that we are going to consider as a negative, that is which is rotating in an anti-clockwise. See, initially, whenever we need to start the construction, at least we should be having some given data, that is either sigma x or a sigma y or a shear stress or basic principal stress. The values we should able to know. Then only we can able to draw the or initial stage of construction of Morse circle can be done. See, once after drawing this circle based on the given values, once the what happens when after constructing this insert circle, so then we can able to start to identifying the values. For example, first say based on the sigma x and a sigma y value, we have drawn one circle according to the we are just now in this Morse circle we are just assuming for the some given values. So based on that some given values, so we have considered we can able to see tau xy, that is what it indicates, below the axis is positive, above the axis is a negative, and sigma x you can able to see the highest value, which is the highest value is there, that we going to consider the sigma x, and we can able to see this sigma y and tau xy, and this is a sigma average, that is sigma x plus sigma y by 2 if I am going to take, that is nothing but a sigma average, and sigma x1 and sigma x2 is nothing but whichever the values we are going to get for a normal stress or a principal stress. So based on that we are going to construct here. See, first now we can able to see this after drawing that circle, what happens, you can able to see one center point. This is what we called as a center, that is nothing but if we are going to measure this part from this point, we can able to identify the radius of this. So now what I'm going to do this, by at the center point we have marked. So now I'm bisecting one arc. So that bisecting arc is nothing but we can, if I'm going to measure from this end to the this end, we can able to identify the sigma x value. From the middle, if I'm going to take from the point C is nothing but between A and B, we have started a marking one line. From that A and B, the center point is nothing but C. So from that C, if I'm going to measure is, so C is the value is nothing but the value of sigma x plus sigma y divided by 2. That is nothing but sigma average. Sigma average is nothing but value of both the sigma x and sigma y. So based on this only we are going to identify the values. So in the real problems for the given values, what we are going to do is nothing but we are going to measure this distance. So initially when we are going to start the construction of Morse circle, we are going to take a scale. So the scale is left to the individual. So the scale might varies from one person to other person. So I'm going to take our one of the standard scale what we're going to measure. Take now after that drawing, when we going to measure this value of, values from this point to this point, and I'm going to measure that values and I'm going to convert to the scale. Then I can able to get the value. What that value I'm going to get, that is what the value of sigma x. Even similar way we can able to find out the sigma y. So like this, based on the scale we can able to identify. Now next step what happens is, once initially basically first we need to find out the sigma x and sigma, we going to find out the sigma x and then a sigma y. So then after what happens then, the sigma x and sigma y. Next step is we can able to find out the tau xy. Tau xy is nothing but a shear stress of axis or a point of x and y, and a shear stress of whether it might be in a positive, or that is a clockwise or an anti-clockwise. So that is the next step. So next what is the condition is, next we need to find out the angle of inclination theta, at which angle it going to be there. So for that again we need to measure from, if it is if you are going to measure with the clockwise means, so I'm going to measure with the clockwise. So if I'm going to measure with the counterclockwise is nothing but if theta will be 180, and for the angle which I'm going to measure with the clockwise, the theta will be 90. That is theta, or we're going to measure with the counterclockwise is nothing but 2 theta. So like this we will start the construction and we can able to start finding the each one of value based on the given conditions in the problem. See first initially we can start to find out the sigma x, sigma y and sigma mean, that is sigma average. Then we can able to start finding the shear stress, whether it might be positive or whether it might be negative. Then we can able to start finding the angle of inclination. At each point we can able to identify. See for example, if I'm take between the at the point R and to the at the point A, we can able to find one angle. From point A to B, what is the angle we can able to find out. From point B to again from point C, what is the angle. So like this we can easily start identifying all the values based on the conditions. See again in the Morse circle the main thing is nothing but about conditions. So what type of conditions is given, or what are the things is we going to mention in the problem, based on that we need to identify. So the basic things, what the basic things required to construct the Morse circle is nothing but first we should know about the conditions. What are the conditions that it will be applying for this. For example, sign conversion, how we can able to convert, take the sign whether it is a positive or negative. So whether first we need to check whether in which direction it is rotating, whether it is rotating in a clockwise or whether it is rotating in an anti-clockwise. So based on this, based on the direction only we can able to identify whether it is in which direction it is rotating, whether it is a positive or whether it is in a negative. On this we can able to identify. Then shear stress. So shear stress we can able to take the notations differently. In the few cases where we take the q or it is a tau. So no, notations is not an issue. So but we should able to follow the procedure. That is very very important to follow the procedure. So so this is the sum of the brief construction about the Morse circle. So we'll see. So from that figure what we can able to see in the earlier conditions, what we look, the coordinates, that is OD from point O we have taken, we are just taken as a reference. So from that we can able to identify the values of shear stresses. And on the two planes, the two planes is nothing but where we can able to see that two planes, one is the x and y. See this is one axis and again this is one axis. So based on this axis only we have started the construction of a Morse circle. From this Morse circle only we can able to identify all those values what we have mentioned here. So the principal stresses and then a principal strains, maximum stresses, minimum stresses,